Alright, so how do I get to that? Okay, and just look at it. Okay, I do it. I don't know if I can do that.
You just get out. That's the mic.
Yes.
That's the one that you run brings up.
And so, okay. So Windows XP.
It's not reading off of this is what it amounts to.
Because that's the whole last chapter. He did, he ended up not using it.
So, what's it for your event?
Yeah.
All the classes that you have, pretty sure. And any classes that aren't connected, you can say one after the other.
Yeah. Should work. It was working last time.
It's like I have the same classes that aren't.
Oh, it actually runs it through an iPhone instead of the iPad.
So it suddenly becomes a lot harder. So you guys, your iPad is a lot less.
Oh, let's see. One.
Good.
Oh, yeah. Okay.
So, this is what you can start.
Yeah.
Can you just do that?
Yeah, sure. Why not?
So,
And then also, I can explain mostly what he's doing for
this.
All right.
So you move it so that it makes it sure that you just. And you have another. Robbie's
Yeah. Yeah. Well, okay.
It's already like 2 minutes late. In fair race, if they ask a question, it's going to take a while. I usually
Yeah. Don't ask a question. I'm gonna be sitting here talking to them. Both me and you were going to be explaining it together.
You can sit like this.
That's challenge.
He's not here.
That's Stephen Ryan.
someone has to say, like, it's not workplace.
Yeah, no, it's the...
I can say question. No, I know what you're trying to do. The large group.
Yes. Okay. Yes. Yeah, because you're going to be doing the last few challenges. There's the last few challenge points. You might as well just go over it.
All right.
Just say, like, you know, the biggest problem is we have a huge talk and, you know, communicate between each other. Who are we missing? Anthony, yeah, we need him.
You guys are all up.
No. We can start without him, I guess.
No.
Well, with some people, I need to wander.
Yeah. Surround! Surrounded. Get out of here. Oh! Hey! Premature clicking. What?
Make it bigger.
How?
You can say scale. I just brought my own phone.
All right.
I understand. I just gave it 2 minutes. That's a signal.
Yeah, you were going on with the last part.
If you want,
Alright, so I'm going to want you to make it control, like take ownership as a grant. So we go with just one.
I guess you just had to wake up so today. No. We should just start. 1 minute. Okay, we got 1 minute, guys. Just bear with us.
Oh, no, it says 12 o'clock right there.
No, that's wrong.
It's a minute off. Don't worry.
Why is it a hexagon if it's round?
Oh, you're going to learn all about hexagons.
You'll love hexagons.
The name of the game that they based it's actually an actual video game. And they actually presented this game as Now,
There it is!
wants to,
Oh, yeah.
Okay. So now that our whole group is here,
Okay, group. Welcome back. Today we have 2 presentations and then we have the award ceremony. The first presentation is by the formidable Surround Group, which is a super group consisting of 3 groups. I'll let them start. They will introduce each group independently as they start talking about their part. And go ahead.
so as the professor said, we are Surround, the 8 of us. And so Surround, it's basically just a board game on the iPhone. And so to start off, we're just going to kind of run through how you play it and how you interact with the actual game. So to start off on this home screen here, we have you have like 3 different buttons. The tutorial, you can click on the tutorial here and it'll show you how to play. And it's pretty cool. You can scroll down and it has a nice little tutorial there for all the stuff. And so, I mean, that's, you know, of course when you start playing the game, you're not going to know how to play the game. So, but then when you click play, you have to enter a username since you're going to be communicating between two different iPhones. And you need a unique username for each person. So we just do my name here because everyone should know who I am. And so this is the board right here. It's just a bunch of hexagons. Zoom in and out. Or you zoom in and you can pan around on the board like that. So to start off with, we can choose a piece. And since we're player 1, we have 2 different choices of colors, red and yellow. We can click on yellow here, and it gives you your piece choices, but we'll go back because yellow is hard to see. We'll go to red. And so all of these letters here, they represent a different piece. So for example, if we click on C here, you can see it's in the shape of a C. And you can rotate it around. You can click it really fast, it rotates pretty quickly. And so since we have it oriented like that, you can click right there and it'll place the piece in the shape of a C in the way that it's oriented. And then you can go back and you can actually check the pieces that you have left here. So you can see usually there's 3 C pieces. And since we used one already, it subtracted 1. And I accidentally clicked one of the line pieces over there, and so I subtracted one of those as well. And then there is a network function, but we can't show it between 2 iPhones right now since it's on the simulator on the actual iPhone here. And so, okay, so I just clicked pass button. And so what that does is it'll just finish the game and tell you like which pieces or which hexes here have ownership from red, and so this is like if the game was finished already. And the dots show where ownership are, and you can see that because no other pieces have been placed on the board, if you only have 1 piece on it, you have a majority for that hexagon. And so the pieces that have a hexagon on them, they have ownership of red. And so if we had another piece of color on there, it would, it might be contested, or it might be a different color, but we can't show that since we don't have another player right now. And so that's pretty much the game board right now. We're going to get in the presentation, which will actually show what some of the complexity and what we had to do to actually get the game running as it is right now. I guess we can get into that. Okay. So, the presentation. So Zaround, we are Zaround, like we introduced. So basically the entire game is hexagons, and you can see the different teams down here. We'll introduce the teams as we go down the slides, but there's 8 of us, and these are different teams. You want to see? Oop, okay. So yeah, so Zaround, it's an iPhone app, like we said, only between 2 people. You can play it over 2 iPhones. You can have multiple games in progress. That's something we haven't implemented yet, but it's something that is going to make it into the final game. And we also have a message service that you can talk between 2 people. We obviously can't show that either because you can't play with 2 people yet. So yeah, we're going to talk about the user interface design a little bit.
So I'm part of the user interface team. I'm Eric Millerin. Also part of the user interface team is Will Sampson and Kathy Gable. So as the user interface team, we had to come up with designs for the actual game and all the other screens for it, as well as implementing them. So as one of the first things we did was think of how to do the board and actually learn quartz, which is the drawing mechanism which we use to actually draw the lines and such for the board game itself. And then the next thing we did was we learned some interface builder for the other menus, like the login screen and the splash screen, which the splash screen also uses a PNG picture to just display a picture to make it look pretty. So, and then moving on, we have buttons. You hit play, as said, and then you go down through different views. And then we also handle some user input with how to press which button, and also clicking on the screen and get touches for that.
Okay, so my name is Anthony, part of the engine team. The other members are Steve and Ashley over there. So what the engine is it's the back end to the user interface. It is what handles like keeping track of all the different statistics of the game, like scores and all that. Actually setting up the functionality of the board, so we're storing like where the colors are and what color owns what hexagons. And we're also like obviously having to implement the rules, like when the user interface, when they select certain lines to send down, we have to validate that and let them know if the validation was right or not, or if the move was right or not. And so the user would pick again. We're also sending data down to the network team, who will go on, we'll talk in just a moment, and they will end up passing the stuff sent down to the other opponent's phone. So kind of to just describe like how we're representing this whole game is we have a 3-class system. There's a board class, a line class, and a hex class. And the board, like a line is just obviously like one side of the hexagon, like what color owns it, and what direction it might be facing, or whatever. A hexagon, we want to know if a color owns it, if they have a grand ownership, which is a technical term for like if one color has all 6 sides to it. And so using an array of lines to kind of form the grid that you saw in the demonstration, we're able to take all the lines, take all the hexes, and combine them in the board with hexes having references to specific lines. And then when a move is, as I said before, when a move has been validated, it'll go back to be redisplayed for the current user. And part of how we capture the move was the user interface. When they draw the lines, there's no actual touching component. They're not buttons or anything like that. So there was a field created, like a field of kind of like an overlaying grid. And it logs where a click is touched relative to the screen, and using like the pixel coordinates from where it was clicked, it'll find the nearest line and then that's the move that will be passed down to us for validation.
All right. My name is Brian McWilliams, and this is Dave Balbert, and together we make up the network team. Now, the main goal of our aspect of the project is to allow a game to be played between two users on two separate iPhones. And to do this, we created an Oracle database, and to which users send their information stored. Other users get that information. And we also created an instant messenger service, which includes a profanity filter. And that's just so users can speak with their opponents. And much of the game data is stored persistently on the server, including information about registered users, their approximate ratings, as to how good they are in the game. Now, the basic network structure is one iPhone sends its information, that gets processed by PHP, and query is sent to the database. Data is stored until another phone requests it, at which point the server sends it out.
All right, so I'm Steven from the editing team. I'm discussing our major challenge, which is when a player is trying to click a line, they're going to touch the screen, and that point won't have anything to do with anything we're trying to do. And so clearly there's a draw path for a hexagon somewhere on the screen. And so based off where a user would touch, it'd give us, their pixel location. But then we'd have to find the pixel location of the nearest point of our hex. So we'd have to run this search to actually find the hex based off a user's touch. But even then, that pixel location on the, what the screen is has nothing to do with the board underneath where the rules are. So even after we found this hexagon location from a user touch, we'd have to then go to the board and find out where that is on the board and actually connect and translate this user's touch location to where we want it on the board and the line that relates to it. And then even after we found that line, we would have to actually span out, and based off what piece the user is using, what other lines also need to be selected and have their color changed. And so it was this very complex process, involved us using multiple arrays with multiple location points and trying to get this all hooked up.
One of the main challenges that we faced was getting the network ready to have many iPhones connecting to the database at once and not having any of their actions interfere with anybody else's. And we chose Oracle because it's good at handling many concurrent users at once. And then another challenge we had was just getting familiar with Objective-C, PHP, and PLSQL, the Oracle's procedural language, and handling error situations between those and user inputs. And finally, as you can see, we have a pretty large group. A big challenge was organizing everyone so we could meet and integrating the aspects of our project.
Yeah, unfortunately, the availability to actually work on the code itself was limited by the platform we're on, like Mac operating system. We're using Xcode programs like Codel's Objective-C stuff, and we can only go on Mac computers for this. Orchestrating that between 8 people who don't have Macs is kind of hard.
Questions?
Any questions for anyone?
When will this game be available for
Oh, that's a different issue entirely, because the people who own the board aren't us, and so we have to actually get into what that entails, and so that's a whole business that we have not discussed yet.
Yeah, I mean, hopefully we could probably make some money off of this game if we put it out there. But again, we didn't actually create the game itself. We just made it for the guy who created the game.
So has he seen your product, and what does he think of it?
They've seen it in the early stages. They have not seen it in the current stages, so
yeah.
We have yet to reshow it to them.
We just finished it last night, so so he hasn't quite seen it yet.
Do you guys have to have like an Oracle license, or is it like a trial version? It's expensive.
The school has it.
It's what are the perks of being a Sonoma State student?
Nice.
All right, so that's it. We're around. Thank you.
Excellent. Thank you so much.
Yeah, no problem. Michael, you gotta figure this out. It's all on the flashback.
That's what I'm talking about. Good job, Ashley. Yeah.
Oh, no. I'm happy for describing the database quick enough, but not rush through.
Please, help yourself.
Really? Okay. Honestly, dude, if you run out of stuff that you can throw it down really quickly, honestly, I can drag it out pretty long. Same with you. You guys are I'm great at GS and this talking.
I just grabbed a soda. Sit down there.
What?
I do not suck you down.
He's never used PowerPoint. He had all the files, so. Yeah. I really should have done that. You know, PowerPoint is really easy. I learned how to use it in about a day. It's really easy. Either I should have pressured you to do it or just
So, what's going to happen is
His people, not our people.
only for your own benefit. People who don't have to read this. And it actually will provide distraction when you're stuff.
Yeah.
Because if you start reading it and you'll be talking and you'll be something different than the teacher is saying. So, and otherwise, you can disconnect it and you can look at this if that's
For me, there's one thing I like. It's a picture of the database. It'll make it easier for the people who don't, but it depends on you. Do you guys want to use that? Okay, yeah. I can use my database picture, that's about it. It's just database.php. Yeah, if they can, yeah, you can. Yeah, that's just a picture of the table. It'll help kind of give a visual aspect of it. Yeah, just close it.
So then you just talk about it.
Am I talking loud? It looked like it was you. Okay, so I suppose I know Michael has stuff. Yeah, because you've got the basis of the program. You talk about the algorithm, and I guess you can go next about coding, and I can talk about it.
I like how we're learning. I can accidentally click 2 different places at once.
Sometimes the screenshot was really good. The screenshot was like really bad quality. I kept like 3 different places. But if you notice, I use the alt or the control print screen over beautifully. I was like, oh, I love this thing already. I'm so proud of myself. I tried to do a whole bunch of stuff like that, and it just would not take the screenshot well. I'll send it over here so I can actually see my data. That would be useful. some more stuff as a test case. Yeah, 7 students and 7 teachers, right? Yeah. Who cares about that's how long it's going to take. Yeah. So yeah, I guess since I'm talking last, I'll just keep in mind that
It's just like nature and make something.
So, I want to thank you, Dr. Stauffer, for taking the time from her busy schedule to come here. We really appreciate it. Thank you.
Being here. Good, the good old days.
Good old days. Of course, I want to remind everybody, and I want Dr. Stauffer to hear, that she's still a faculty of Computer Science Department. So our next talk is by 3 of our students who have worked with Dr. Ravi Kumar on a project-independent project, Michael Harris, Nick Hughes, and Casey Blair. The topic of the talk is Schedule Optimizer. And if you could give some background to it, that would be great. Thank you.
So the program that we're making is basically to take student input from, well, just figure we start off with computer science students, branch out from there, of what classes they want to take in the next semester. And then the professors will put in all of the classes they're going to offer. And it will optimize a schedule that has the minimal conflicts. And so, I mean, the reason I'm doing that is because next semester there were like a bunch of classes that were all at the same time, and I was like, there's got to be a better way to do this. So we started working on this project. And so the algorithm that I made up to create the schedule is fairly brute force, but not completely. So basically what I did was put in the schedules or put in the classes onto the schedule, and then scored each conflict based on how many students were in each class that was at the same time, and then started just rearranging them until an optimal schedule is reached. And so then we have Casey, who worked on the user interface.
Yeah, to take input from the user. You set up a PHP supply to the website, and it takes your email address, your CWOP account email address, as your user ID. And so if you have to have CWOP in the account name to sign up. And so you pick out your classes, and they would get sent, your choices get sent to the database with priority for which one you want to take the most, down to the least. I think we all have 10 classes. Yeah, and so it takes that, sends it to your users table, and when you want to, it's called the C++ program, it would take a bunch of queries from the database and it dumps it into a text file. And then that text file gets passed to the C++ program as a parameter, and it runs its program and sends the output to the screen, which PHP takes and puts it back up on the website. So you can see which class is most popular, all that kind of stuff.
And I set up the database. It's like the last group was talking about. We use Oracle because it supports a lot of users, and we can keep the data pretty securely on there. A big thing that we made sure of is, like Casey said, the user ID is a CWolf account name, and that's about the most sensitive information that's on the server. So if someone actually did get onto the server, because we're not great on the security side right now, they're not going to find anything important in there. The biggest thing that we had to keep in mind, at least for me, when I was designing the database, was that we're not storing the classes that students are taking. We're not setting up the schedule for them. We're simply storing potential classes, what times they can be, professors and students, and like what classes they could be taking or what they want to be taking. We're not setting up any of the schedules. Ultimately, the professors will take the input from this and they can take it or leave it, but they will, take the classes, and then the students have to sign up for the classes themselves. So we're not storing any information about, student passwords or ID numbers or what their schedules are, or anything about even paying for classes, anything like that. We just have one table for users, which will have both teachers and students. We just have some Boolean values that we can check whether they are a professor or not, depending on whether they can change what time a class will start. That's obviously, if you're a professor, you can do that. If you're a student, we don't want students being able to mess with that. And then we have the class table, which is just each specific class. And this one took a lot of collaboration between all three of us to figure out what we wanted in it, because there's a lot more variables for setting up a class than you'd expect. I mean, for instance, we just have the class number, which is easily identifiable for the class, a name, a description, the teacher. That's how we know which teachers are for the classes. Then for instance, type, we have D, L, A, and B, which means there's discussion, lab, what were the last two? Lecture and activity. You don't consider that when you're signing up for a class, but that's actually, there's 4 different types of classes. So we had to make sure that, if we have a lab and the discussion together, we have to actually think of it as 2 separate classes, because we don't want to have a bunch of classes with a bunch of extra variables that we don't use in case it's not a lab, so it doesn't need any of the lab variables. So we had to make sure we had a type for that, and then we have requires, which will tell us whether it requires a discussion or lab connected to it. Allowed start, I believe, didn't go over that too much with Michael, but I'm pretty sure that's about what time during the day it can start. It's in half an hour increments. We just have a string of zeros and ones. Ones for when we think we can have the class, zeros for when we can't. That once again goes into his algorithm and helps us plan when the classes can be. Start hour, start minute will be tentative, pretty much perpetually. Whether we think we're pretty sure this is when it'll start, so students can see, oh, it looks like this class will probably be at this time, and they can check for, according to their schedule. But of course, this is always probably going to be changing as students add more data. Num blocks, once again, that was for his algorithm. As simply, we thought of the classes as half an hour chunks, because it's a lot easier to schedule classes if they're just in blocks, rather than thinking of it as, oh, it's an hour and 15-minute class. It's just 3 half-an-hour blocks. And then you just chunk out data like that, because it allows room for breaks as well. And then we have things like num days, number of days of the week, and then num days is just days during the week, so you see 0 to 8. And then days of week being Monday through Friday, Monday through Sunday, I guess. Daytimes, meaning morning, afternoon, or evening classes. And then can change being whether this really is a set in stone class. If it can't change, we're going to have that as 0. So that this class is going to be at this time one way or the other, so students will know. And then finally will be the students in classes table, and that's specifically just to link students to classes that they want to take, so we can find out for his algorithm how many classes or how many students want to be in a specific class, or what priority. Like if a class has 1 student in it, obviously a class with 50 students in it will have a lot higher priority. And this will be where we store all of our data, and that's about it. Any questions?
So do you guys actually have it's something that you can show us right now about how it works?
Do you have output maybe?
Did you get any output?
Well, I mean, I have the output in a text file.
Yeah.
Yeah, let me skip
Yeah, because we've been using test data, and it's been somewhat successful.
So, I mean, the input text file that the C++ program reads looks sort of like this. And so, I mean, it's kind of messy, but here's the allowed times. So you can see, short range of times, then break at noon, another short range of times, that sort of thing. And then the output is basically just a list of classes. Here's which days they'd be on, and the starting time based on the half-hour block. So 20 would mean 10 o'clock.
So the one nearest to the top would be the best selection of the one you want to have.
The order they're sorted in is just the order that they came out of the vector.
Right.
So the user interface would just resort it according to the department or any other. I mean, they're sorted based on number of conflicts. So the ones with the most conflicts are at the top.
Right.
You could also see which class is most popular by how many people and what priority.
So if any of you are interested in providing test data for us to use over the summer, at some point in the next couple of weeks, we'll probably have the website up, and we'd love more test data.
Thank you very much. Let me ask the CS faculty to please come forward. And there's some more booths. All right, so we're going into the second phase of today's schedule. We have three different types of awards today, one for the Computer Science Club students and one for WICS, and the Distinction Awards. The Computer Science Club. The Computer Science Club plays a very central role in our program. They kind of provide what we don't. We provide support for the classroom, and they provide support for the students outside of the classroom. They kind of provide the bridge between the students and us. Not that the students don't talk to us, they do, but kind of a more generalized types of information. They provide different services for students. They bring different people to give presentations, right? By people from different companies, or host resume writing workshops. So we really appreciate their support. We appreciate the work that they do for us. And this year's president of the club is Eric Miller.
Speech.
What do we do? And there's Krista Walker.
Walker without an L.
That's just never correctly. The vice president of the club. Fred Wong, the secretary of the club. Anthony Caballero, the club treasurer. And William Sampson. All right. Can I now ask everybody who just got an award to come here and take a picture with the faculty? Group hug.
We stand. You cheer me, you gotta get in more. All right, got everybody.
is designed to help support women as they go through both being a student and a professional in computer science. It helps to support men too, and actually has become quite an active social organization. They've organized a number of things over the last year, including last Friday. What Friday was it? We had, when you're on sabbatical, you lose track of the days. We had our annual social, and Dr. Stauffer very generously opened her house. I think there were about 15 of us there, maybe more than that. About half men and half women, so if you're male, don't feel that you don't belong. And this year's officers, President Stephanie, is she here?
No.
Stephanie Schmidt?
She has a class.
Oh, she has a class. Okay. Vice President Chris Walker. And treasurer is Leslie Prince. Thank you.
All right.
So thank you very much, and we'll let you.
Richard Luding, you gotta get in the middle.
Get in there.
There's so much space in there.
All right. We got 1, 2, 3. Wait. All right.
So the next award is graduation with distinction. And we're proud of all of our students. We really value every one of our students. And of course, we award those students who excel in our program. And it's this semester, we have 5 students who were awarded graduation with distinction. And the requirement for this graduation with distinction is 1 GPA of 3.0 or higher, and the ability to internalize information. Really, courses that we teach, each one of them is independent. The ability to pull them all together and transcend each one course and pull it together into a discipline, into a program. And finally, to have contributed to the life of the department in activities such as programming contests, such as membership in the clubs, but I've actually been officers of different clubs. So we honor them, and we have 5, like I said, this year. And Anthony Cavallero is our first. Please come here and take a picture with us, and then stay right here so that. Ted Chan. William Malani. Eric Miller. Jeffrey Nyana. Oh. So a couple of announcements. One is the CS courses enrollment. Thank you very much, colleagues. CS, the enrollments in our different CS courses. I want to mention to you, I know that many of you signed up for courses that are you need for your GE and also fill up quickly. And kind of put computer science courses behind. I want to encourage you now to sign up for computer science courses so that they do not get canceled because of under enrollment. Please keep that in mind. CRA survey. This is Computer Research Associates, the survey that those of you who are graduating this semester and also this summer, you've been sent a survey, you know who you are, and we only have so far 4 of you haven't filled out this survey. I want to urge you to, if you haven't done so, please go ahead and fill out this survey. We will, on the graduation day, gather in front of Darwin to take a picture of all graduates and faculty. Please be sure to come there for that picture.
At what time? Like before?
After. Yes, I would think that that's perhaps a better time. Afterwards, basically, it's harder to tell when people come. But afterwards, everybody's here, so please just walk as usual, walk through the crowd, and eventually, as kind of quickly as you can, please gather in front of the picture. Thank you so much. I appreciate you coming.
Go computers.
Just saying.
Everyone knows.
Is it going to be online? Okay. Probably like a Sonoma State University Computer Science Department. Okay, CS1. Alright, just want to make sure. Okay, no problem. Thank you.
Never noticed that. Those are like really flip flops. These are like
Let me give this back to you. This is the one for Stephanie, and maybe just give it to Corey, and you can talk to Corey. Secretary, but I don't think I had a secretary. No. Yeah. No, I don't think they did. I think I remember
Yeah, I figured that's probably what we can work on. Yeah, I can definitely help Casey with the side. Or at least designing each things. You can still work on the output. But that's what I'm saying. You don't need to work on that. I know how to do it. I can do it. Then obviously it works. You can focus on the stuff that I don't know how to do, which is the output of the text, and making sure that that and taking input and all works. I could just set up the interface and draw an application or like that.
Oh, I say.
Yeah.
Maybe something I'm not sure.
How are you?
Yeah, I suppose when they create an account, I'll have to look up when they create an account. Yeah, no, what you would do is you
create a camera. You send them a password. Store it. Oh, I see. Send them their password.
No. You send them a password.
Send them a link to I was going to say, send them the link to a page. It'll go to that page sending information. And then it'll say, okay, now we can actually make this account. We can talk about all that on Friday. That's getting a little ahead of ourselves for now. I think I should just see the rest of it. But honestly, I'm not just saying this. I'll be busy this summer, pretty busy. We should still collaborate over the summer. Make sure we get this thing really working well.
I'll be on campus like the whole summer, so.
I definitely won't be.
But it's more than Skype Explorer or whatever, right?
Yeah, exactly. Oh, you have Skype?
Of course, I've got everything.
Yeah, no, I have Skype. I've been setting up everything.
Yeah, there we go. I don't know if you're totally
That might be why.
Oh, what did you do to that?
So this is a distribution.
Oh.
Okay, there's two different distributions. Which one's yours, A or B?
The one on the left.
This is my class at Contra Costa College. That's you guys. Okay, so here's something to ponder. I mean, same me, same lecture, same textbook. Why such a big difference? Yeah, it's got like scratching my head. Morning class, my Monday, Wednesday, 8 o'clock class, basically the same thing. I don't know. Okay, so that's something to think about. I mean, this is a community college, right? Community college, state university. You guys are supposed to be the top California students. Okay. I think they just. What might be some explanation? Okay, does anybody know where Contra Costa College is?
East Bay.
East Bay, where in the East Bay? What city is it in? San Pablo, which is right next to Richmond. So mainly it's a low-income student population. Anybody, does that maybe explain why there's a difference here? I mean, you know, this is what we do. And I'm going to look at some statistics. Big difference. Why? Right? So, you know, this is what social sciences do, or even hard science. How can we explain the numbers? Anybody have a hypothesis? A possible solution? What? Yeah, actually, more of the students there did pick calculus.
More students that stay are full-time students. So we have more
That's no, not necessarily. They're pretty much full-time students, and they're transfer bound. They're all transfer bound, so they're going to go to a CSU or UC. A lot of them are trying to get into Berkeley.